Welcome to Flexing the Future, the Entras podcast on the energy transition and flexibility. By us, Frank Allaerts,
Jens Batens,
and Jeroen van Vrachem. In this podcast, we'll discuss the impact of the energy transition on the flexibility of the industry in Belgium and in Europe.
Not among ourselves, of course. Alternatively, we'll ask true experts in the field to share their knowledge, insights and vision with you. So welcome to Flexing the Future, the Entras podcast about energy transition and the role of flexibility in this process. Today we have Joannes Laveyne and Sam Hamels with us in our studio, so welcome.
Thank you.
Thank you.
We want to start off immediately with a question. So what is your personal view on the current state of affairs and the future? Is the energy transition on its way? Which evolutions would you expect?
If I can start, Johannes. Well, we're at a critical junction. I think most of the really low-hanging fruit has been picked. The exciting times are starting. This is very interesting for people like us. The big things start happening. At the same time, there's more and more stress, of course, in all fields in politics among the private players. And I'm both afraid of some things going wrong, especially, for example, in the building sector. That's one part of this energy transition, renovating all buildings to label A by 2050. Not particularly optimistic there, but there's, at the same time, plenty of stuff to be optimistic about as well. And I think flexibility at the residential level, which is our focus as researchers, is one of those things.
I think it was William Gibson who said the future is here. It's not evenly distributed yet. And I think it's also the case with energy transition. We see that a lot of things are happening in certain fields, especially, for example, on the production side of energy. Energy transition there is happening very quickly. But there are still other fields that are, not going equally as fast, and I think that's indeed, like Sam says, quite a challenge to get all the sectors up and running equally as fast in the energy transition.
Mm-hmm. Okay, thank you. We'll take one step back and first let you introduce yourselves, of course. So maybe Sam, if you want to shortly introduce yourself and what your current position and activities are.
So I'm a postdoctoral researcher at the Department of Economics at Ghent University. As a person always focused on the energy transition, I'm not like most of my colleagues who are focused on banks and labor market, etc. Mm-hmm. So a bit lonely on this faculty when you focus on the energy transition. But nonetheless, very active together with Professor Martin Ovare, researching particularly this field of how can we make households participate in this story of flexibility. And there we, of course, need this technical knowledge of how the energy system works and so forth, but we're particularly interested also in how the humans participating in it work, studying what drives them, what makes them make certain decisions, etc.
Mm-hmm. Okay.
I'm Joannes Laveyne. I'm a colleague of Sam, but I'm working for the Faculty of Engineering. And we're active on the same projects. We both have projects, the two projects which have been funded by the SPF Economy, indeed on researching residential flexibility. So how can we make the residential electricity consumption more flexible and more aligned with the production of, for example, renewable energy, but also how can we avoid peaks on the system from happening caused by the residential electricity consumption. And I'm mostly focused on the technical aspects. So how can we actually unlock the technical potential of residential flexibility? What are some drivers? What are some barriers, technical barriers still preventing that? And how can we solve them?
Mm-hmm. Okay, thank you. So both researchers at the University of Ghent. Okay. I was told you're specialized in what is called distributed flexibility. Maybe we can start with what is it? What is distributed flexibility? I don't know. Start.
Yeah. So we all know that certain things need to happen for the energy transition, specifically in the section of households. Most people know that electric vehicles are coming. Electrification of heating your home is also coming with heat pumps. And if we know that there will be millions of electric vehicles and heat pumps in the long-term future, we immediately realize that this presents both a big threat in a way, that if this happens in an uncontrolled way and all of this electricity consumption gets dumped on the electricity grid in let's call it a dumb way, that this would not be good and present the grid operator with big challenges. At the same time, it's of course a huge opportunity, and that's what we focus on. How can we make all of this additional electricity consumption at the household level participate in the electricity system in such a way that it helps out rather than burdens this system?
Mm-hmm.
In a way, what we're trying to do is turning heat pumps and electric vehicles from liabilities to the system into assets to the system, so they can actually provide additional flexibility and also support the electricity system as a whole.
Okay, yeah. And is it more on a technical, operational point of view? And do you think that's the most difficult way, or is it also the human after the asset who will needs to adapt to the new reality? Or
it's both, but indeed it begins with the technical potential, which Joannes already mentioned. So it maybe makes most sense to start there.
Mm-hmm. So what we see is that especially the new assets that are coming, electric vehicles, heat pumps, also home batteries, and in a certain way also PV installations, they offer a lot of technical potential for adding flexibility to the system. There are, however, some technical barriers first to actually unlock that flexibility. One of the things we see is that there's currently a complete lack of what we call interoperability between those systems. If you have a PV installation, electric car, and a heat pump, and you want to turn those assets into flexible assets, so they can help you not only lower your energy bill and reduce your capacity tariff, but also offer services to the grid, you need to be able to control these devices. And that's a very big technical barrier at the moment. There are some ways to control them, but they differ from type of asset to another type, from brand of manufacturer, etc., etc. So there's a large technical barrier currently that needs to be overcome in order to actually tie all these assets together into one big system that can provide this flexibility.
Okay. Yeah.
So that is one big aspect that is currently still ongoing.
so you would need some kind of standard probably in the future, or that would converge to a standard, or do you see that different?
I don't think there will be one standard, especially because it has been tried before, and mostly what you get is if you want to push one standard, you just get an additional standard. We think it's really up to interoperability. So actually making sure that if a device uses a certain standard, a certain interface, a certain protocol, it's documented. And the documentation is there, it's open, and other manufacturers or service providers can actually use that documentation to make sure that they support that interface, support that protocol. And when all these interfaces are documented, then you can work on solutions that make these assets talk to each other. And I think that's the main, or rather the biggest driver. And what we see is that a lot of manufacturers, or they aren't aware that there is a need for this. They have these interfaces, but they aren't aware that someone actually wants to use it to control their asset. That's one thing. Other times we see that manufacturers actually shield this information because they want to create a walled garden, or they want to see, or they don't want third parties access to their devices. So there are some technical barriers, but also some, I wouldn't say legal barriers, but some
Commercial aspects maybe also.
Indeed.
And to make it very concrete, if you think, for example, about exploiting the flexibility that's inherent in a heat pump, when you talk to heat pump manufacturers and you tell them, oh, let's exploit this flexibility, then they may, for example, respond by saying, oh yes, okay, maybe we can heat the sanitary hot water for taking showers during the sunny hours of the day. That makes sense and doesn't impact the user too much. So we're open to that. But when you then say as an academic, no, let's also play with the thermal inertia of the building. Let's heat the building a bit above what the user is asking. If he's, for example, asking 21 degrees, let's every once in a while make it 22 in order to then be able to turn off the heat pump for a few hours. Later in the day, when electricity is more expensive, there is less solar production, etc. Then quickly you get reactions like, whoa, quite conservative.
Touching the comfort of the
of course,
of the people.
It's for many players at the moment a no-go to play around with such things. And so to a degree, we're today still in a phase, we feel as academics, of ripening the minds of the involved market parties as well. Of course, there's differences. Some of them are already more ahead than others, but this will happen and it needs to happen. So we, as a university, want to help figure out how we can make it happen. And that's why, in addition to the technical potential that we already talked about, we talk as researchers, as economists, about the behaviorally corrected potential, by which we mean, okay, the asset, the heat pump or the electric vehicle, maybe on paper, purely technically, you have this many kilowatts and kilowatt hours that you can shift around. But how does the story change when you study the human interacting with it? Because the user will introduce all kinds of additional constraints. Going back to the example of the heat pump and overheating the building a little bit, you would then need to have an app, for example, that gives a user some options, some fields to fill in to say, can we overheat every once in a while in order to be able to turn off the heat pump, as I explained. This will save you this many euros on your electricity bill. But please tell us, how often can we do this? By how many degrees can we maybe overheat or underheat your building? And these user-defined behavioral parameters, let's call it, will of course create the zone within which engineers' algorithms can do their job to optimize the consumption of the heat pump.
Yeah, okay.
There's also a big difference between what people say up front they are okay with. For example, you can turn my thermostat 2 degrees lower, no problem. And what is actually they then allow to happen in practice. And we see there's sometimes a big difference there between people estimating their flexibility potential quite big, and there's a big room for having their heat pump, for example, turned up or down. But in reality, it can be much smaller. And so I think that's one of the main differences with industrial flexibility. With industrial flexibility, if you send a set point to a certain device, to an electrolyzer, whatever, it reacts on it and it follows that set point.
There's no human interaction.
Indeed. If you do it with residential flexibility, there's still the human in the loop. It can have you need to be able to cope with this uncertainty in a way. Because you don't know exactly what the human, what the end user at that moment is doing or will allow, for example, their heat pump or electric vehicle to do. And so I think it's also very important that and especially it will be required for residential flexibility. You will have to have a very large number of participants so you can actually average these effects a little bit out. And but it's a different approach on flexibility than, for example, in an industrial setting.
Yeah. Okay, quite interesting. So that brings me to one of my next questions. Indeed, what is the difference between the distributed flexibility, which is, I think, mainly at the residential, at the homes of people, and then, of course, the other side is industrial flexibility, maybe the large scale flexibility. You briefly mentioned already the difference. Where do you also see the benefits of both, or should one be promoted more than the other, or?
It's in a way $1 million question. I think the jury is still out whether both will be able to fully exploit what is possible. Of course, the grid operator Elia makes forecasts about what does the demand side, the flexibility look like in the long term? How much flexibility are we going to need to deal with uncertainty in bigger and bigger wind and solar production and with other things? But it's unclear whether this future need for flexibility can be already fully met with only going fully for exploiting industrial or only for residential, or whether you really need to fully exploit both in order to come close to what is needed. My personal intuition is that you will need to exploit both because the need will just be so large. If you look at these huge quantities of renewable production capacity by 2040, etc., just having a little prediction error in the amount of wind that will actually take place gives you gigawatts of difference that you have to deal with from hour to hour, unexpected surplus or shortage in production. So then consumption needs to react as well to deal with that. Now, there are of course big differences between the two. I can start by talking about some of them. Of course, when you go to industry, you're talking typically with the technical guy from the company that is very knowledgeable about some of the technicalities regarding flexibility in electricity consumption. This is totally different when you're dealing with households. So one big difference is, of course, how do you keep it simple enough so that people also understand it? We often have to remind ourselves as academics that we should not forget that we could come up with all kinds of very complex ways of exploiting the flexibility in residential electricity consumption. But if it turns out to be some kind of a black box that households do not understand and do not trust, therefore, then that may be the primary reason for them not wanting to participate in it.
Again, the human aspect.
Exactly. So understandability of how the flexibility works is a key thing, I believe. And then another big thing, which maybe Joannes can talk more about, is the fact that when you go to a big industrial player, let's say there's probably some room to pay for some additional hardware if that's needed to enable the flexibility to take place. But this amount of room is very small in the household context, because you simply cannot afford to say we're going to need to put a flex box in your garage of costing 1,000 euros, because if you have that kind of a hardware cost to enable a household to participate in this story, then immediately you blow up the commercial case for it. So things have to be extremely cheap and extremely lean. And therefore, this standardization thing also comes back. If hardware assets can talk with each other in a very effortless way, that doesn't require a lot of additional development and hardware being set up.
I think it's our understanding, or our belief rather, that for residential flexibility, if you need additional hardware, then the business case will never work. If you need to install additional hardware, sometimes an installer has to come. Also, you need to provide support to the end customer if something isn't working, etc. As long as you need additional hardware, I think the business case of residential flexibility will be very difficult. And that's why in the future, it will need to come from the devices themselves. So they will have to be interoperable without having additional devices being plugged in, etc. They will have to have some what we call an API, so a programming interface that can be accessed over the network or even over internet. And in that way, all these devices can work together without having this what we call additional transaction costs, because every cost, every investment you have to do to make something work is transaction cost. And currently that's one of the biggest barriers preventing residential flexibility from gaining a large market share. There are a lot of companies currently investigating and trying to unlock this residential flexibility, but we see that the business case is very hard. of course, if you compare it to industrial flexibility, yeah, indeed, like Sam said, if you put one flex box there or one device that can control an industrial asset, you're already sometimes talking about hundreds of kilowatts, megawatts. But in order to have this the same volume with residential assets, you need hundreds, sometimes thousands of these assets, and having a low or rather being able to avoid having to install additional things that will make or break the business case for residential flexibility.
Okay, yeah, that's a clear answer. I think that's a main difference maybe between then the industrial flexibility and the household flexibility or the distributed flexibility.
Maybe to add one thing, I think a similarity, by the way, between the two is that you clearly have certain assets that make your life easier if you want to, well, let's say easy assets and difficult assets in terms of exploiting the flexibility. I'm not an expert in it, but presumably one kind of industrial player and what kind of machinery he has is way more complicated and difficult to exploit the flexibility of it. And for another one, it's easier. It's the same in the household setting. We can clearly say, I think, today that the order goes like this. If somebody has a home battery, this is a super easy thing to exploit the flexibility of it. Why? Also, again, from the behavioral side, you can play around with a battery, saying when it should charge and discharge in order to achieve some goals. And this basically never affects the comfort of someone. Sort of in between is then the electric vehicle, where again you have a lot of freedom. People usually sleep every night, so throughout the night you can play around with the charging schedule of the vehicle without comfort being affected. But I guess probably the hardest thing is then the heating, where quite immediately you're talking about an impact on temperatures in the house. And so there the behavioral aspect becomes largest, and also the difficulty sort of exponentially increases.
And to be clear, if we're talking about residential flexibility, we're actually mainly talking about these categories of devices. A lot of the residential electricity consumption is fixed. It's mostly related to preparing meals, etc. And that's not something we believe that people will shift in order to save some euros or rather contributing to the system or something. It's 7 o'clock, you want to eat, you will make your dinner. So the existing electricity consumption is quite fixed, but there is a lot of additional electricity consumption coming ahead, and that will be the main source of this of this flexibility. So this added electricity consumption.
Okay, yeah.
It's an uphill battle sometimes. People quickly say, "Oh, yeah." Playing around with electricity consumption of a household, you want me to cook in the middle of the night because then the wind is blowing? No, that's not what we're saying. In fact, we constantly emphasize that we think automation is really key. Having basically zero impact on the amount of time, effort that people have to spend mentally on this stuff. It just needs to do it for them in the background, lowering the electricity bill. Without them having to think about it too much or having to change their lifestyle in any way.
Yeah, okay, quite interesting. Yeah, especially the fact that you indeed have different assets which can be flexible. So you mentioned EVs, electric vehicles. You mentioned heat pumps. You also mentioned home batteries or small scale batteries, and that there is a difference in type of flexibility, but also the ease of valorizing this flexibility. Maybe there is some parallel with industry as well, where you of course also have lots of consumption, but also different machines, different processes, assets. And there also some aspects might be more easy to release the flexibility than others. So there are some parallels between them as well, probably.
Yeah, I believe so. In for example, like Sam said, batteries are one of the main easiest sources of flexibility. I think it's the same in industry. If you have a process with a lot of buffers where you can store energy or process that require a lot of energy, but they can store products in their buffer, for example. Those are also the low-hanging fruit and the most easiest to provide flexibility with. But if you go then to heating, this is a process in the residential flexibility that interacts a lot with end users, with the humans. Probably in industry you also have certain processes that have an impact, for example, on personal scheduling.
The work schedules, etc.
Work schedules, indeed. And they can provide flexibility, but there you are constrained by other non-technical aspects as well.
Yeah, okay. Yeah, I like the parallel between, you have a home battery which stores energy, stores electricity, and you have like an industrial process with a buffer in between. You can also store product. But I think maybe a difference is that the buffer will probably already be there because that's inherent in the industrial process. But the house battery, the home battery, that's something that people really buy for flexibility. I think that's not something which is standard in every household.
Yes, it's quite peculiar to see also how certain market players think about this. Not to name names, but I've seen someone say recently, well, okay, maybe people are buying home batteries for wrong reasons because they expect something of them. And for example, if they buy a small home battery, that this will lead to them being able to fully consume all electricity produced by their solar panels. Of course, it does do that to a certain degree. But then market parties jump on this and they say, okay, if they're going to buy that home battery anyway, it's already paid for in a sense, then we can go approach them and say, well, actually, if you want to squeeze some additional value out of your home battery, we could add some of our algorithms on top of it, and your battery could do way smarter things. As an economist, from a marginal perspective, that's a nice thing to do. At the same time, you can still question whether you should buy a home battery specifically for that purpose.
Indeed.
So
Yeah.
it's you can look at this from different positions.
I was wondering what your opinion or your idea is on this. Would you advise your mother, for example, to buy a home battery so she could valorize her flexibility, or do you say home batteries don't really believe in this?
Maybe Joannes will want to start on this.
Let's say we are sometimes surprised for the reasons people buy home batteries, and it's I wouldn't say it's in most cases this way, but in a lot of cases the incentive or the reason to buy this home battery is different than a purely financial one. Sometimes it's also the ease of mind, so they don't have to worry about capacity tariffs or they have their net metering regime that's currently no longer in operation or is being decreased in Flanders and in Belgium. They can still act like it's that way. They can optimize the self-consumption, etc. And this ease of mind also, it has a value, and customers are prepared to pay for this ease of mind. However, looking from a pure like from a helicopter view and looking at the social welfare as a whole, as the electricity system and society as a whole, I can't really recommend home batteries for this perspective, because again, if you a home battery, all those little home batteries, they are just a big battery split up between a lot of houses, and again you have certain transactions costs and additional costs for each battery has its own inverter, its own grid coupling, etc. So you actually increase the total costs instead of just having one big battery somewhere connected to the transport grid, which can much more effectively render the same system services. So would I recommend a home battery? I personally, I wouldn't really recommend it because, like I said, the business case is very difficult. And if people really want a home battery, I would suggest keep it as small as possible and just have it to, for example, reduce peak consumption and things like these. I think that's the most efficient way of using these resources.
Okay.
I think at the very least that we can all agree that let's say we're happy, to put it mildly, that the subsidy that was in place for a while to buy home batteries, where as a society, as government, we are giving money to people in order for them to incentivize them to buy home batteries. This was not the best decision. Of course, people are free to do what they want. If they want to buy a home battery because they somehow enjoy what it can deliver for them, fine, free world. But again, also as an economist, would I recommend it? No, because if you're going to spend order of magnitude 5,000 euro on something, if the goal of that something is to make you money, then probably a home battery is not the wisest thing you can choose to put that 5,000 euro in. There's probably some alternative investment opportunities, may even have nothing to do with energy that will give a better return.
Yeah. Okay. Yeah.
There's also the exposure to the long term, because if you look at the investment case or the business case of a home battery, if it's even there, you're talking about 8-10 years. But how will the energy landscape look like in 8 years?
Also difficult.
Yeah, it could be that the tariffing or other technologies are then there, which make this investment no longer a good investment, or much worse than you originally thought. So it's also with this in mind, I think it's quite difficult to recommend these types of devices.
Okay, yeah. And does this then also apply to large-scale batteries? Because Joannes, you also mentioned it. It might be more interesting to have one big battery instead of 1,000 small batteries. But of course, the whole business case and the idea that the energy landscape can change over 3 years, 5 years, 8 years, 10 years is also valid, I think, for that case. How would you look at large-scale batteries? Will they be really needed in the system, or could we do with the flexibility which is already there at residential or industry?
I think for large-scale batteries, the investment case is quite different, especially because with home batteries, the largest part of the battery will still be used to optimize self-consumption. And that's a totally different use case than large-scale batteries, which will be used for arbitrage, for example, between periods of high and low electricity price, to balance the grid, to provide ancillary services, so supporting services to the grid. And I think because large-scale battery is free from this optimizing self-consumption constraint, you can use it in a much more, well, let's say, lucrative way, and really use it to optimize on certain aspects of for, like I said, arbitrage or day ahead energy markets. And the business case there will probably be much better, and in especially compared to home batteries. And also, if you look at the investment cost, so the capex per kilowatt, a big battery will always be much cheaper than a lot of small batteries.
Don't forget also, we have to sometimes be careful when we're talking about the flexibility, what we are talking about precisely. There's of course so many value streams that can be captured. Selling services to the grid operator is certainly one, but for a household, Joannes mentioned it, self-consuming your solar production to a higher degree is another one. And probably the way I would see it play out is that the big batteries that we see pop up like mushrooms at the moment in Belgium will specialize and capture perhaps to a large extent the markets for certain aspects of this flexibility. For example, frequency control, which requires second-to-second response speeds. Maybe something that these big batteries are just way better suited for. At the household level, again, when you need to deal with these kind of very quick response times, then you really need to set up high-performing IT infrastructure in every household, make sure that the connection to maybe to the grid operator's server or whatever is really top-notch. And quickly, these kind of things start to require expensive hardware, start to ruin the business case. So probably the answer is a bit varied in the sense that some flex stuff, let's say, will be great at the household level. Others, other value streams won't be.
Yeah. So we mentioned flexibility, but in fact, it's a broad term. Of course, you have different kinds of flexibility. So if I understood well, big batteries might be good in really the technical ancillary services, providing services to the grid, technical thing. But then on the household level, it might be more shifting energy with PV panels and using it when the sun shines.
Yeah, indeed. I think there are a lot of startups right now working on providing this technical flexibility also with residential assets, so FCR, so frequency control, and other ancillary services. But I think these will be in the future outcompeted by bigger batteries, because these bigger batteries just have the scale. It's much easier to provide these services at a lower cost. So if you have your bidding ladder, they will be in front. They will, and I think the market will probably go there. If we're talking about flexibility with residential assets, we're mostly talking about shifting energy. It's and aligning energy consumption with the availability of cheap renewable energy. I think that's the main business case or use case rather for residential flexibility.
By the way, it's something we didn't mention yet, but a really big deciding factor in this story is whether or not you give control. Could be as a household, but I think the same applies in industry. Whether you give control of your assets to an external third party. In the household setting, what does this mean? Of course, if you're a household with PV, with an electric vehicle, you could just yourself react to price signals. Your EV may be smart enough in order to make sure that the way it charges is very smart and saves you money on your annual electricity bill. But this is something else than putting your autograph on a contract where you say, okay, I'm your signature on a contract where you agree that a third party can now control and steer the charging of your electric vehicle. This is, especially for households, maybe something more difficult to accept, especially if you're talking about heating. Some third party from outside your house can send a signal that suddenly turns off your heating. I think a lot of people will have issues accepting something like that.
But on the other hand, if you look at countries like Germany, where they already have special tariffs, for example, the EVU sperre, it's a special tariff you can get as an owner of a heat pump, and you have to allow the energy company, I think it's up to 2 hours a day to control your heat pump, block it, or even make it consume more, so it charges its domestic hot water buffer. You get a lower energy tariff, and we see that if there is something tangible, a tangible benefit for the end user, they often are willing to give up a little bit of their control.
But there should be a balance, of course, between their gains and what they
indeed
what they offer. Yeah.
And I think in the future, probably if when a lot more people have heat pumps and electric vehicles, we will also see special contracts appear, energy contracts for these kinds of assets. And the regulation is already working a little bit towards it, where you can have, for example, a certain energy tariff for your conventional residential electricity use, so just your TV or cooking, whatever, and then a separate contract, for example, for your electric car, separate for your heat pump, and it will come with some other constraints. For example, being having to reserve, for example, 20% of the battery of your EV for the service provider of this contract to play around with and optimize the charging. But you will also get a better suited tariff for this. And I think indeed it's still to be seen where the optimum balance between those two factors is, but I think that's in the future this will become quite common.
Okay, yeah.
And as always, you will have your early adopters, then the big chunk of people in the middle that come after, and some laggards that will, maybe only do it in the very long term or even never. And that's very normal. So, and today it's still, I think, an empirical research question for scientists about how big those 3 groups are and how quickly they will start to adopt this technology. Right now, it's of course still peanuts. The amount of people that have a dynamic electricity contract, that have a home battery, and are basically offering these flexibility services, that's a very small number, and in the hundreds or maybe thousands in Belgium. So if it is even that.
But I think it can become quite big quite fast if the assets are there, if we all start having electric cars, etc. For example, if you look at I think it was Finland, where up to 30% of the people already have dynamic contracts, which is quite big. And I think it was a month or 2 ago, there was a big imbalance on the network, and residential consumers actually reduced during, I think, an hour or 2, reduced their electricity consumption, and the total impact was in the order of, I think, 1.4 gigawatts, which is enormous. And it shows that the potential of residential flexibility to work is there, and it can deliver quite a big service or support to the system if it's unlocked in a straightforward and transparent way.
Okay. Yeah. I have one last topic I want to talk about, and that's cybersecurity. We mentioned the steering of assets, giving away the control of your EV, of your heat pump, etc. Do you see this as a risk? Should we focus on this, or is this maybe a bit too much spun out in the media? Because there was some news articles about PV inverters being potentially exposed on the internet. How do you see this?
Yeah, I'll start. Joannes knows more, but for sure, it's not something we can just ignore. It's clear that there could be a risk. It's clear that we need to pay attention to this in order to avoid big issues. I mean, it's critical infrastructure in the end of the day, our electricity system. So let's not add new weaknesses to it. I'm certain that certain people in the cybersecurity world are shivering when they think about the prospect of all of this additional data streams being opened up and access being given to hardware, etc., through some server. At the same time, not personally being an expert on the cybersecurity piece, but still, it should certainly not be something that we let stop us. I mean, it's something to pay attention to. As to how big the risks are, I'm sure Joannes can say more.
Well, I think it's part of a bigger and a broader trend where we're moving to an information society if we're not already there, and we connect a lot of more things to the internet than we used to, because this creates new opportunities. But with new opportunities, of course, there's also additional risks coming with it, and we need again to balance these, and we need to be aware that if we connect more and more devices, and especially critical devices, energy devices, to the internet, we also have to take into account that this needs to happen on a secure way. And perhaps currently the evolution was a little bit too much focused on the opportunities that connecting energy devices to the internet bring. For example, you can watch the production of your PV inverter through an app, or you can control your home battery, etc. A lot of opportunities, but this security part also needs to catch up now. And if there's something that, for example, the shift to shifting all our financial transactions to the internet has shown that it can happen in a safe way if we put attention to it. And I'm sure that concerning energy, we can do the same if we just have enough attention towards it.
Okay, thank you. I think we should wrap up because we're almost out of time. I have one last question for you, and that question is: what developments regarding the energy transition or technology are you closely watching today, because you think it will maybe become big in the future, or will have a really positive impact on the energy transition?
You want to start?
No, you start.
Well, for sure. I mean, it seems clear that, especially in Belgium, with all of our company cars that are now going to be electrified in a speed-up way because of regulation, this fleet of large batteries is coming. It's coming quicker than most people think. And certainly this is something to keep an eye on in the coming years, because both the threat and the opportunity are huge, and they are quite near term. So we see today already lots of interesting things happening there, apps being developed. We're also part of project in which those apps are developed to do smart charging. So I'm hopeful there. At the same time, I also want to mention what am I thinking about currently in the energy transition. I'm paying close attention to what's happening to European industry in terms of are we going, I don't want to say too fast, but we just need to pay close attention and make sure that we do not reach our CO2 targets, of course, by just making industry move to other parts of the world. So I firmly believe that it's possible to keep them here, even to attract other industries to Europe and to make them participate in flexibility. But at the same time, it's very clear that you have to do this in a very thought-through manner. And to the degree possible, as academics, we certainly want to participate in that process in order to decarbonize the European economy in the right way.
Mm-hmm. Okay.
Yeah.
For me, it's solar panels, especially solar panels installed behind the meter, so residential installations. Why? Solar panels have become dirt cheap. It's a no-brainer to install solar panels as an end user, and I think they have become or are becoming the most transformative driver in the whole energy transition. We see, for good or for worse, a lot of energy being injected by solar panels. For example, if you look at the energy mix in the Netherlands, which have in the last 2, 3, 4 years have installed an enormous amount of solar panels, we even see that during winter days, a large percentage of the electricity mix is provided by these solar panels, and this is transforming both the production industry, so the investment decisions for new production capacity are driven by this fact that during every day, especially in the future, there will be still longer periods where solar energy will provide most of the electricity consumption. So on the production side, there is now an incentive to prioritize flexible electricity consumption, no longer base load, but if you build a new power plant, you know it has to be flexible because all that cheap solar energy is there. So this is a totally new paradigm than we had in the previous years. But also on the consumption side, you see consumption also needs to become more flexible to be able to optimally make use of this cheap renewable electricity. Mm-hmm. And so also if you make new investments in industrial processes, you know from the start you need to build it for flexibility, because that will be the most efficient way of investing.
Designed for flexibility,
Indeed.
as they say. Yeah.
Indeed.
Mm-hmm. Okay.
And I think this solar energy is the main driver for this. So keep installing solar panels.
Okay, keep it in mind. Joannes Laveyne Sam Hamels, thank you very much for this interesting talk. I think we have some interesting views on energy transition. So thank you very much for this talk.
Pleasure.
Thank you.